Greetings everyone. I'm Paryan Shablani and I'll be giving a brief overview of technical architecture of the Talawa plugin GSOC project that we have been talking about for a couple of weeks now. So, we know all about plugins. Let's directly deep dive into what the architecture is. The plugin is just an extensibility system in Talawa that so that a third party contributor, third party users can come up, make their own plugins, and extend the feature of the Talawa application. The Talawa plugin can be as simple as adding some sort of color theme to the Talawa application. It can be as simple as adding a payment or an AI plugin. Now, Talawa plugins, we will need a way to store all the plugin code, and we'll need a way or a store to install, uninstall, and enable, disable plugins. Very similar to VS Code Marketplace or Chrome extension store. That this will be called, in our case, will be called as a plugin store. Now, we will contain all the plugin metadata in our plugin store DB. Metadata means readme files. If you go to Express npm right now, you will see that there is metadata for Express library, and you will see the amount of downloads. You see the graph of the downloads happening in the Express. You see who has created this Express, the repository. This is all the metadata of Express. This is stored in some kind of DB. You will want this similar DB to be implemented in our plugin store. This can be as simple as a Postgres DB. More important point to discuss over here is how are we storing code, the source code of the plugins. Now, one approach mentioned in our GSOC idea is maintaining separate repositories for each Talawa plugin. So for different plugins, we'll have different repositories. Now, we will anyways, the third party developers who will be developing this plugin will always have a separate GitHub repository that will store all the code of the plugin, and they will just mention the link of the repository, and then the code will be published to the Talawa plugin registry. The more important thing is, where do we store this code? Do we store it in a repository and do we access it from a repository? Probably not the best way to do it. If we store it in our Talawa code base, then it will become too bulky, because if we have 1000 plugins, it will become too bulky. If we store it in another repository, if we have, let's say, one repository for every plugin, we will still have 1000 repositories to go over and then trying to import this files from the repository. It will be too tough of a task, and even if it's not tough, it's not the best way, the most industry standard, the most common best practice to do it. And as an organization, we should always follow best practices. So after a lot of research, I have got an access. This is an open source repository that is an alternative to Visual Studio Marketplace. So Visual Studio also has its own extensions. If you look at this, there is an extension column which has a Visual Studio Marketplace where you can install. You can look at this and you can see install, uninstall, disable extension. This is an open source alternative to the similar what I showed you right now. It provides a server application that manages VS Code extensions in a database. So what we want is that we also want something like this. We also want our metadata to be stored in a database. And what Visual Studio does is that they store the code of their extensions in an, let's say, an object storage called as S3 storage bucket. Now you can store it in an Amazon S3 bucket as well. Now the question is, what do they store in this bucket? And the answer to that problem is a packaged version of their plugin or extension. This is what we want to implement for Talawa as well. This is what the aim is to implement for Talawa. The aim is to package the code, all the files, all the folders of the plugin, and store this packaged version in our MinIO S3 bucket or AWS S3 bucket. The reason for this is, first of all, we will package it like zip unzip, or we have always downloaded datasets from Kaggle. When we download datasets from Kaggle, we get it in a zip format. Why? Because datasets are large, they are bulky, they have higher storage datasets. and if you want to access those data sets from a browser and download them from a browser, you typically don't want your system to slow down. You don't want your client's system to slow down. And in order to do that, they usually zip it, they usually package it, so that so that the amount of downloading, the storage becomes less of downloading that particular uh, data set. And then you can extract that, you can unzip that as simple as possible when you usually do in your folders or in your files. Similarly, we will zip in simple terms, we will package them and we will unzip those files when a user or an admin tries to access the code of the plugin. We will unzip those files and then use them. This is the first principle approach to how we will store the plugin code in a system. We will package them and store them in a min.io or min.io S3 bucket. And whenever an admin does a plugin management call, for example, I want to enable, disable, install, uninstall, there is plugin management calls. If I want to install, if I'm an admin, I want to install a plugin to my organization, then I will tell to the plugin store that please help me install this. The plugin store will go to min.io, it will fetch the file, fetch the zipped file, the packaged file of the source code, and will just download this file on the backend server or in the client side application. Once this is downloaded, we can unzip this, unpackage this, and then use it as normal users. Now we can see that only admin is allowed to do plugin management calls, as because we have organizations and every organization will have admin and a lot of users. So it is only makes sense, the motto of admin is to manage the whole organization. So the motto of admin should also be to manage the plugins for the organization. And the moment admin wants to install a plugin from a plugin store, this event will be propagated to all the users, and this user will also try to fetch this zipped file from the plugin store. But they won't be able to fetch this zip file from the plugin store unless until admin has installed this plugin, because we want always admin to dictate the terms of plugins in an organization, not a user. This is the difference between a user and an admin that we want to have. Inherently, we can also think about having users access the plugin store and having some specific plugins, allowing users to access some specific plugins, but then this leads us to write RBAC logic, which is role based access control. We will have some plugins that will only be available to admins and some plugins that are available to both users and admins. This creates a lot of complexity. I would rather propose that if we want a functionality where user can request, if user wants a plugin, then user can just put a request to the admin of the organization that, sir, I want this plugin, can you please install it and distribute to the organization. This would be a better approach, it would be a more easier approach, and it would also create a very good distinction between admin and user. This makes sense. Now we will move forward. We have discussed this, so I won't discuss deeply about this. I will now discuss how is plugins loaded onto the system and what is the approach behind it. We always want, point number one is, we always want the plugins to load on the client side of our application, not on the server side of our application. Why? Let's say 500 users. 500 users are in 10 organizations, 50 organizations, we have one organization, we have 50 users. All these 50 users have different combinations of enabled, disabled plugins, right? Some user has 3 enabled plugins, some user has 2 disabled, 3 enabled plugins. So this permutation and combination is too much. And when an API is handling all the plugin management, then API has to figure out that which event, let's say you're getting an event from an admin of an organization about to install a plugin, then the API has to figure out that who should receive this event and who should have propagate this event to. This will be too much of a logic to write in backend, first of all. Second of all, this will also be very unoptimal. Even if you figure out to write a logic for a backend, which is not very tough, it can be done if it solves a problem. But rather than solving a problem, we are probably creating another problem, right? Because if we do manage our plugins in the API side, then the problem is it is very unoptimal. We have to hit 500 users about the plugin data, and the thing is that plugin and the application of user, the client side, will communicate very often. They will want to render a button, they will want to render a particular style. The moment you turn to advertisements page, you will want to render a payment button. Moment you enter the click the payment button, you will want to have a window to pay with PayPal, pay with Razorpay, and so on. So this interaction will be a lot of times you will have to hit the backend, get the data from backend, and if it is even a slight unoptimal, it will be easily visible by the users. Hence, thinking about scalability, thinking about how fast our application should be, how intuitive it should be, it's always better and more industry standard to write the plugins in the client side application. This is how Chrome extensions and VS Code extensions also work. They also try to make sure they always make sure that the plugins are always handled in the client side applications. The plugins are loaded in the client side applications, executed in the client side applications, and then showed results on the client side applications. There is no communication in the API backend for plugins. This is the industry standard approach of how plugins are worked. Now, if you are clear on why I am choosing to always load plugins on the client side application, we have one more advantage to this. We don't have to think about scalability. No matter how many users we have in our applications, every user will have their own browser. If they're using Flutter, if they're using mobile, then every user will use Dart because our application is in Flutter, and Dart also has ability to load plugins using isolates, which I have already discussed in this proposals. I would urge you to read that portion as well if you get the time. So the thing is, you can always load plugins on the client side. It will also have some benefits. Now, this is one optimal approach, one scalable approach to solve a problem. Now we'll move on to the next scalable approach, because we also have to make sure that the amount that we do not want to flood the client side application with all the plugin calls and lot of plugins running in the client side application, as it will just burn the computer out or burn the phone out. We don't want to depend on how many cores or GPU does this phone or this laptop have. The phone has no GPU, only has cores. So we shouldn't depend on how many cores this phone has. We shouldn't depend on how many cores this laptop has, how many RAM it has. We should always make sure that we are independent of what client configuration is, and hence we have thought out lazy loading. Now let's say I have 3 or 4 extensions enabled. Okay, one of them is payment extension, one of them is AI extension. Now whenever I am scrolling, I am going through my Talawa application, I will only want payment plugin when I'm in an advertisement page. Okay, when I'm trying to start an advertisement, I'll have to pay for the advertisement, or when I'm in a donation page, when I'm trying to donate something, I'll want to pay with PayPal or Razorpay. This is the only 2 times I'm going to need a Talawa plugin, payment plugin. Now think about it. Does it make sense that from the start, when I log into the Talawa application, that the payment plugin starts and keeps running, whether I am on advertisement or funding page, doesn't matter. It will still keep running. It doesn't relate. It doesn't make sense, right? We don't want payment plugins until we are at advertisement or funding, and hence we will uptake that approach. We will lazily load plugins. The moment when user reaches the advertisement page, even better, when user clicks on create advertisement, then is the only time we need that payment plugin. The moment when user decides that I want to fund, that is the only time we need payment plugin. Why should we try to even load before that? This is what is called lazy loading. We always want to lazily load all the plugins. The full code of plugins is never loaded immediately upon installation. Instead, only metadata is loaded. Metadata means all the events needed by that plugin. Because plugins will need to hear that, sir, are you on advertisements page? Sir, are you on funding page? If you are, then we will load the whole plugin. So the plugins will always have an event listener that will listen if you are on advertisements or funding page. If you are on that page, then good. If you are on donation page, then good. They will load the plugin. If you are not, then that event listener will keep listening unless you are on advertisement page. So we will need some kind of metadata of plugin or registry of all the plugins we have stored in the memory. But we won't need the whole code until and unless we are at that point in application where we need that plugin. The actual plugin code is only loaded dynamically when an activation event is triggered. For example, when a user navigates to a feature that requires the plugin. This is what is lazy loading. Why we want this is because to prevent having multiple plugins running in the browser or in the phone. Why to run multiple plugins when we only need them in our foundation and donation pages? This was the mode of what I was trying to optimize the Talawa plugin architecture. I will just give a very short overview of a very small architecture. I have already explained this a lot in my proposal, so no need to give a very detailed analysis. Anyways, this video is going very longer than expected. So a Talawa plugin architecture will be having in a browser, we will always have main thread, and then we will want the plugins to work in a separate isolated environment. Why is that? This is one of the most important questions to answer for both browser and mobile. You will always want plugins to remain in an isolated environment which is not not in the main thread. Why? Because let's say if I'm scrolling to Talawa application and the payment plugin is a very computationally expensive plugin. It takes a lot of computational power to just run the payment plugin. If I click on pay, the computation is very large. If I put this code, if I make sure that the plugin code is in the main thread, not in an isolated environment, then the front end will lag, user will face difficulties, right? Because you are taking the computational task in the main thread as well as loading the front end in the main thread. These two things working together do not work very nicely together. It may lead to lagging. That is probably the biggest issue. We don't want this. We are want that our app to be intuitive, not so distractful and irritate to work with. So in this case, what I thought was to separate the logic for plugin and separate the logic for the main Talawa app. In this way, we will always make sure that whenever plugins start, they start inside a web worker. Web worker is just they are not inside main thread, but they make sure that you do all the computational part outside the main thread, and you can communicate with web worker and main thread using this post message or message channel. This is how you work with a web worker. You can start a web worker and you can communicate with this web worker, communicate the main thread and communicate with the web worker very easily. This is what I mean by a Talawa plugin architecture. You can work with the main thread very easily. Now I have a very small demo to show you. This demo will demonstrate me writing I have already written code for web worker which starts a web worker and makes sure that it loads a plugin, a sample plugin which just have a very few it just loads a plugin, renders a plugin button in the advertisement page. This is the code to start a new web worker in a browser like Chrome. It's very easy. It needs to refer to a worker file called worker.js. The standard naming convention has been used. Let's quickly dive deep down into this implementation. Okay, this has happened a lot of times. You log into the application and you see we have threads. If you do inspect, we see we have threads and we have only main thread going on. What in our present case scenario, I have made sure that our plugin is only we have a payment plugin, and this payment plugin will only be loaded on advertisements page and no other page. So this is called lazy loading. If I would have been dumb, I would have made sure that I would start this payment plugin right now and right now only. But I want lazy loading. I want to save the computation power for the client side. So to make sure this, I will click on manage. You see there is still one thread. I will also click on console to I have some logs when you will see when a web worker starts. This is the time when a web worker will start. The moment I click on advertisement, a web worker will start. You will see the main thread. So let's focus on main thread first. We have thread and we have only main. Alright, the moment I click on advertisement, we will see a web worker. See a worker.js has been created here. This is an isolated environment in which our plugin has been started. If you look at console, look at this. Created a new plugin worker instance called this. The plugin received a message, import plugin URL, import plugins, plugin sample index.js. This is how import has been done. Then the plugin is responding, I am a plugin. You can see the logs. This is very easy. Now the moment I click on create advertisement, remove the inspect, you see a pay with PayPal button. If I disable this plugin right now, you won't see this pay with PayPal button. Obviously I've not written the code to disable a plugin, but it's really easy to write it. Right now I've just created a condition of enable is equals to true. If I keep it false, this all things won't happen. This is what I'm talking about. This part is only handled by web workers. This is rendered by web workers. If you look at the logs, console logs, the render button, the plugin event, my web worker is logging that render. I am giving you an event of render button, and please render a button, pay with PayPal. Now if you don't trust this, then I will show you the implementation at this point. This is plugin manager, and what it says, plugin worker instance. What is a plugin worker instance? Let us understand that. It is a plugin worker instance that initializes a new web worker using the worker.js URL and imports the given plugin URL. In our case, our plugin URL is crc plugin sample index.js. It is inside our file system right now, but we will want it to in the future to be from a plugin store. That would be more optimal, and that is the end goal. For sample, we have done this, and we have multiple message types here. Message types: plugin event, message event from plugin. And if you look at this, we have one called message event.render button. What does it do? It renders a button given on the and the name of the button, the placeholder is message.text. Now if I give you this index.js, this is the plugin code. If you see plugin sample index.js, this is the same URL you see here. So this is getting imported on the web worker, and this runs api.render button, pay with PayPal. This is the RPC call. It's not pure RPC call, it's just a function call at this point. I've just mocked it, but we can convert it into a RPC call very easily if we want to, but it will take a lot of time, and a demo application we will do it in the real implementation in the end. So if you look at our plugin worker manager, the worker.js file, you will see that it initializes a render button function that just posts a message that type render button text. So if you see here, type render button will be here, and the text will be pay with PayPal. And in the advertisements page, I'm just trying to prove my point here that the code I've written is very true here. So if you look at advertisements page, you will see, most probably you should see styles.add button. No, okay, wait, gosh. This is where I have implemented everything. Just search the wrong file for a moment. So what is this? We have created a function here and it renders a button. If a message type is rendering a button, then it will receive the render button event with text this, and it will just render a button. So set plugin visible, and we will set the plugin text to message.text. So we have a state variable that will get initialized here. We will state for initially this is false, initially this is empty. If this is true, then this also needs to be filled, and once this is filled, here you can see pay with PayPal. So this is the extra code that I have written in the file and in the worker.js to start a demo application. This can obviously be extended. This demo can also be extended. We can we can create an RPC call as well, but I don't. This summarizes my architecture of how a plugin system should work in a isolated web worker environment. In our mobile application, a Flutter application, which is at this point, we can have Dart. We have Dart, and in Dart we can have isolates. They are not exactly similar as web workers, but they can work the same way, and we can have the same functionality of having an isolated environment where plugins can run. So in my Figma design, if you another thing about implementation is, once I click with pay with PayPal, it sends a message to the web worker. Sir, someone has clicked pay with PayPal. Can you process this payment? So the plugin worker is my web worker is responding to the message. Sir, I received your message. Plugin event pay PayPal window. So my motto of plugin PayPal is that once I click with this button, a window of PayPal should open where the payment can be processed. So this is my plugin saying ki please open a PayPal window, and this is just a sample plugin, so I just created a log. But in the serious implementation, we will want a PayPal API to start here and make the other payment processes done. We can also have similar functionality in funds, which we don't have because of this. Because of migration to Postgres, we are not able to I'm not able to access this page, so I chose advertisements. We may or may not need payment for advertisements at this point, but this is what we have right now. Thank you very much for staying up this long. I have created a demo. If you want, ask any questions on Slack. please go ahead. I can also extend this demo functionality for whatever reasons you want. um, I will also give another small demo, just a small video following just this demo, so that it becomes more clearer for you what this demo is all about. Thank you for sticking along. I am Prayansh, and hope to contribute more to Palace. Thank you.